Hello everyone, let us integrate these two famous functions, sin²x and cos²x. Before then, I think it is important to derive two important functions that can help us integrate this easier. Alright, remember, if you have cosine of 2x, this is the same thing as cosine²x minus sin²x. So from here, you can either make sin²x or cosine²x the subject, which is going to replace this one. All right, let's start with sin²x. Since we have sin²x here, I would like to write cosine²x in terms of sin²x, which is simply 1 minus sin²x. Therefore, cosine of 2x is equal to 1 minus sin²x for cosine²x. Then we still have minus sin²x. Cosine of 2x equals 1 minus 2 of this sin²x. And from here we can switch these two terms. Let's take negative 2 sin²x to the left, which is going to transform it to positive 2 sin²x equal to 1. Then this becomes minus cosine of 2x. Now let's divide both sides by 2. Sin²x is equal to 1 minus cosine of 2x divided by 2. So instead of integrating this function, you can confidently integrate this one. Let us box it here. Now let's do the same thing for cosine. Remember, from here I decided to change cosine in terms of sine. Now we are going to change sine in terms of cosine. Therefore, cosine of 2x is equal to cosine²x minus sin²x is the same thing as 1 minus cosine²x. If we expand the bracket, every single time will change a sign. We have minus and minus, that becomes plus. Altogether, we have 2 of this cosine²x, then minus 1. This is still cosine of 2x. And now we can make this one the subject. If you take negative 1 to the left, it becomes positive 1. Therefore, 2 cosine²x is equal to 1 plus cosine of 2x. You can now divide both sides by 2. And cosine²x is equal to 1 plus cosine 2x divided by 2. So instead of integrating cosine²x, you can now integrate this. You can see the only difference between these two is the sign. This is positive for cosine, and we have negative for sine. So now let us integrate the two functions. We have the integral of sin²x dx is equal to the integral. We can even factor out 1 over 2, right? Remember, this is where we have it. You can factor out 1 over 2. Then inside you still have 1 minus cos²x. So you have 1 over 2 times the integral of 1 minus cos²x dx. Now let us integrate. This is equal to 1 divided by 2 multiplied by the integral of 1 with respect to x is x minus, if you integrate cosine of 2x, that will give you sine of 2x. But you have to divide by the derivative of that function inside, which is 2x. The derivative of 2x is 2. All right, then plus the constant of integration. If you like, you expand. By expansion, you have 1 over 2x minus sine 2x divided by 4, because this 2 will multiply this 2, right? Plus the constant of integration, and we are done. Now let us do the same thing for cosine²x. The integral of cosine²x is equal to 1 over 2 times the integral of what? 1 plus, do not use minus. Minus is meant for sine. we have cosine of 2x dx. Let's integrate. This is equal to 1 divided by 2 multiplied by the integral of 1 with respect to x is x plus. If you integrate cosine of 2x, you get sine of 2x. Divide by what? Derivative of 2x, which is 2, plus the constant of integration. Let's expand. This is equal to 1 divided by 2x plus sine of 2x divided by 4 plus the constant of integration. And these are the two antiderivatives. This is for sin²x and this is for cosine²x. The only difference is that we have minus here and we have plus here. And we have two important formulas that can always guide you. You can see them right here. If you're asked to integrate sin² nx, for which n is constant here, a multiple of x, then it is going to be 1 over 2x minus sine of 2nx. Whatever n is multiplied by 2, right? Then attach your x. Then divide by 4n, 4 times this number here, whatever it is. The same thing for cosine. This is very important. Thank you for watching. Do share to your learning colleagues. Bye-bye.